When you look at the image behind me, you'll notice a water abstraction technology. It's part of a water supply system in Queensland, Australia. How is it connected, and how does it move from its original source through the system and eventually to you, the consumer? After watching this module, you'll recognize the 6 functional groups of a water supply system and be familiar with the Compendium of Drinking Water Systems and Technologies from Source to Consumer, or the Water Compendium for short. You'll understand how system templates are used to describe the movement of water through different functional groups from source to consumer. Now, let's take a look at a water supply system serving a small town. For the few months each year that rain falls, in some areas water is collected from rooftops and stored near the household, then treated using a ceramic pot filter before drinking. For those living in the more rural outskirts of the town, water from a shallow aquifer is accessed with a protected dug well equipped with a hand pump. The water is carried home by water users in jerry cans, where it's disinfected with chlorine treatment and kept in safe storage containers. For the residents in the more urbanized center of town, their water is supplied through a pipe network, beginning at the reservoir, flowing downhill by gravity to a water treatment plant. It's then pumped to an elevated tank for distribution to the town's residents. Rooftop storage containers allow households to maintain a reliable supply. And as you can see, several water supply systems can coexist in the same location. The color highlights show the different functional groups that together make up a water supply system. A water supply system is defined as a system for the collection, transmission, treatment, and storage and distribution of water. A functional group, on the other hand, refers to a broad category of technologies that perform a similar role or function within the water supply system. Graphically, we can visualize a water supply system as a matrix of functional groups, each with a different role and with different combinations of technologies. Most water systems consist of 6 functional groups that work together to move water from source to consumer. We have source, intake, abstraction, treatment, distribution and transport, and lastly, household water treatment and safe storage. Here's a system template which shows the 6 functional groups arranged in columns. Each column lists technologies, such as the pump types under the abstraction functional group, or sources like groundwater or spring water under the source functional group. You can map the combinations of these sources and technologies to show how water moves through the water supply system. Let's take a closer look at a system template for the piped water system shown earlier. The source is a reservoir located at a higher elevation in the hilly area surrounding the town. At this source, there's a protected lake water intake, as well as an abstraction structure where large volumes of water are transferred by gravity flow to the water treatment plant. At the plant, the water undergoes multiple treatment steps to remove sediments and microorganisms. Treated water then goes to the distribution and transport stage with solar-powered pumps moving water to an elevated storage tank. And then from there, the water flows into the town's distribution center and on to consumers. Households then might adopt water treatment or safe storage practices, for example, storing water in safe storage containers on the rooftop. Note that it's not always necessary for water to pass through every functional group. For example, the rainwater harvesting template shown here excludes the abstraction, treatment, and distribution steps. However, you'll note that water always moves from left to right across the template. The Water Compendium provides a total of 9 system templates, such as the centralized surface water treatment and rainwater harvesting templates just shown. There's also templates for manual transport of water, desalination of brackish and seawater, among other examples. However, these are not exhaustive, and planners should compare and iteratively revise their own water system template as new information becomes available, especially considering things like source water characteristics, water quality targets, the regulatory environment, and sociocultural preferences and acceptance. By prioritizing the use of locally available resources and capacities, each system template will be a unique representation of a particular locale. So, in summary, you were introduced to the 6 functional groups of a water supply system using the example of a pipe distribution system serving a small town. This is one of 9 system templates that visually show how different technologies are combined to deliver water from source to consumer. Now, some water systems might skip certain functional groups, but water will always move from left to right across the template. Finally, we talked about how system templates are adaptable tools and they should be iteratively revised as new information becomes available. So if you're interested in learning more, take a look at the Water Compendium on the course reading list. Can you make a system template for the water supply serving your home? If you can, we'd love to hear about it on the course discussion forum.